There are tiny comets orbiting foreign suns. And human beings can detect them. 6 times, about 800 years ago, dark things passed between the bright yellow dwarf star Kepler 3,542,116 and Earth. They were small in cosmic terms, about 330 billion tons, 300 billion metric tons. That's about the size of Halley's comet, or just 1/245 millionth the mass of Earth's moon. But they were big enough. They blocked a fraction of the light that was streaming outward from the star. "800 years later, the sensitive lens of the Kepler Space Telescope, a nearly meter-wide piece of precision-cut glass floating in the darkness of space, detected that dimming as Kepler 3,542,116's ancient light reached this solar system. The star seemed to dim quickly, though nearly imperceptibly, as the small dark things passed in front of it, from Earth's perspective, 6 times between 2009 and 2013. Three times it dimmed deeply, and 3 times it dimmed faintly, at irregular periods over those 4 years. This is a familiar signal to astronomers, the same sort of dimming that has allowed them to spot most of the 3,728 exoplanets discovered as of February. But the small dark things acted like tiny planets only in the beginning of their trek. That's not how exoplanets, basically great symmetrical orbs, look to Kepler. But it is how a comet, with its long dusty tail, would appear. In fact, it's how a team of astronomers predicted such comet passers-by would look way back in 1999. In a study due for publication February 21 in the journal Monthly Notices of the Royal Astronomical Society and first released in 2017 on ARXIV, a team of researchers report that these dark objects are the first exocomets, or comets in another star system, ever discovered. The team wrote that they're not sure exactly how many comets there were, casting shadows on Kepler's lens during that period. Or there may have been a smaller cluster, with some comets making multiple crossings. Perhaps just one comet was orbiting its star very tightly, they suggest, though they were unable to fully figure out the orbit of a single comet that would have produced the 6 irregularly timed shadows. Kepler 11,084,727, also a yellow dwarf, dimmed once, faintly, just like Kepler 3,542,116, where the 6 shadows were found. Those 2 stars are near twins, the astronomers wrote. Both are very bright and of similar size and magnitude. and they're somewhat unusual in the Kepler dataset, they wrote, which tends to target cooler, sun-like stars. Perhaps, they suggested, comets, or at least comet transits visible from Earth, are more common around stars of this type.